Hello, this is Mrs. Shartle. The purpose of this video is to show you how to calculate infusion rates, as we did in class. You must first determine if an electronic infusion device is being used. If a device is being used, then you only have to calculate the infusion rate in milliliters per hour, and then calibrate the infusion device accordingly. However, if an electronic infusion device is not being used, then you must calculate the infusion rate in drops per minute, and then manually set the infusion rate by adjusting the roller clamp on the tubing and counting the number of drops. When we must manually calculate the infusion rate in terms of drops per minute, we may choose one of two methods to do so. We may use the formula method, or we may use dimensional analysis. The formula method first. In this example, the prescriber has ordered the following fluids to infuse in 12 hours for a client without an electronic infusion device. The prescriber has ordered 1,000 milliliters of D5W, which is 5% dextrose in water, 1,000 milliliters of NS, or normal saline, and 500 milliliters of a solution containing both D5W and NS. Since all fluids must infuse within 12 hours, we need to calculate the infusion rate for the total volume. Adding these volumes together, we have 1,000 milliliters of D5W plus 1,000 milliliters of the NS plus 500 milliliters of D5W and NS for a total volume of 2,500 milliliters of fluid. To use the formula method, we simply need to recall the formula. Well, the formula is X drops per minute is equal to the volume in milliliters times the drop factor in drops per milliliter divided by the time in minutes. To use the formula method, we simply need to substitute the appropriate figures into our formula. Well, looking back at our example, let's determine what the appropriate figures or important figures are. In this example, we have a total infusion time of 12 hours. We have a total volume of 2,500 milliliters, and our drop factor is 15 drops per milliliter. So, to solve, we will simply write X drops per minute is equal to the volume of 2,500 milliliters times our drop factor of 15 drops per milliliter divided by our time. Now in this example, our time is given in hours and we need our time in minutes. If we simply take our 12 hours multiplied by the 60 minutes per hour that we know is a conversion factor, our hours will cancel and we get a total of 720 minutes, which we can now use in our formula. Doing the math, 2,500 times 15 is equal to 37,500 divided by 720, which is equal to 52.08. Since we cannot calibrate in less than full drops, we need to use our rounding rules. Looking at our tenths position, which is a 0, since that is less than 5, we simply leave our whole number as 52 drops per minute. And that is our answer. As we reviewed in class, you may also use the unit rate or hourly rate in this formula. The hourly rate, or X, milliliters per hour, is found by dividing the total volume, which was 2,500 milliliters, by the total time of 12 hours. When we do the division, we get 208.33, which again we need to round. Looking at our tenths place, we have 3, which is less than 5. So rounding, we are left with 208 milliliters per hour. Now, in this case, then our drops per minute calculation becomes the volume of 208 milliliters times our drop factor of 15 drops per milliliter divided by the 1 hour converted to minutes, which is equal to 60 minutes. Doing the math, 208 times 15 is equal to 3,120 divided by 60, which is equal to 52 drops per minute. Now let's look at solving this same problem using dimensional analysis. Recall that in dimensional analysis, it is important to consider the units of measure to solve a given problem. As we did on the previous slide, let's underline the important information. We have a total time of 12 hours. We have a total volume of 1,000 plus 1,000 plus 500, which is equal to 2,500 or 2,500 milliliters of fluid. And finally, we have a drop factor of 15 drops per milliliter. We need to find drops per minute, so we're going to begin by writing X drops per minute. And since we want drops in the numerator, we begin with the information that contains drops. Since we are given a drop factor of 15 drops per milliliter, we will use this ratio first and write 15 drops per 1 milliliter. Since we are paying attention to units, we see that we now have milliliters in the denominator. We do not want our final answer to have milliliters in it, so we find a relevant ratio that will allow us to cancel the milliliters that are in the denominator. Looking at the problem, we see the total volume of 2,500 milliliters. We will use this in the numerator and since the volume must infuse in 12 hours, we can use 12 hours in the denominator. Now we see that we have hours in the denominator and we need minutes. Well, we know that 60 minutes is equal to 1 hour. We can use this conversion factor to cancel hours in the denominator and leave us with minutes and leave us actually with minutes in the denominator. So we write 1 hour over 60 minutes. Canceling the units, we see that hour in the numerator cancels with hour in the denominator, milliliter in the numerator cancels with milliliter in the denominator, and we are left with drops in the numerator and minutes in the denominator, which is exactly what we want. Performing the calculations, we have 15 times 2,500, which is equal to 37,500, divided by the product of 12 times 60, which is equal to 720. Doing the division then, we are left with 52.08. And again, because we cannot calibrate in less than full drops, we need to apply our rounding rules. Since 0 is in the 10th position and it is less than 5, we simply keep 52 drops per minute as our answer, which is exactly what we got in our previous examples. Now you will want to review this video until you are comfortable using both the formula method and dimensional analysis to calculate infusion rates when an electronic infusion device is not available. If after reviewing this video and completing the homework problems, you are still experiencing difficulties using either one or both of these methods, please be sure to see me in class. Thank you.